All right, guys, we're going to start this little lesson off with just a couple examples, hopefully kind of familiarize ourselves with radicals and exponents and how they work together. So this is the square root of 5 cubed, and so I'm going to rewrite this in a couple different ways. The first way I'm going to rewrite this is, I know that 5 cubed is just simply 5 times 5 times 5. So this is an equivalent expression. I can also break this up using the properties of a radical or a root into the square root of 5 times the square root of 5 times the square root of 5. Okay, all equivalent expressions. And so what I want to do is rewrite this as a fractional power. So in doing so, essentially I'm going to take this this form here, and I know that that's equal to the square root of 5 cubed. So we can actually, without doing this work right here, we can actually go straight from this form to this form. But if I want to rewrite it as a fractional power, I need to turn these things into fractions somehow. So looking on the inside of the parentheses here, the square root of 5, I know any square root is technically a 2 right here. So whatever's on the inside, this thing is raised to the first, and that's why we changed it into this form. But it's raised to the first, and it's a square root. And so this is actually equivalent to x to the 1/2. So these are equivalent expressions. So any square root is x to the 1/2. So what's on the inside I can rewrite as 5 to the 1/2. And what's on the outside stays. So that's 5 to the 1/2 raised to the third power. And so if I want to, I know by my exponent rules, I'm going to combine these two into one expression. A power to a power, and multiply these two together. So I end up with 5 to the 3/2. And that is this expression written as a fractional power, 5 to the 3/2. All right, so we're done with that one. Let's check out over here. Let's kind of go through the same process. Here you can see we've already got it written in kind of this form right now. So what we need to do is take what's on the inside, rewrite that as a fractional power. So I've got the cube root of 4. So that is 4 to now the 1/3 because it's a cubed root. That's how we can rewrite this. And that's to the 8th power, again, multiplying, or power to a power. So this can be rewritten as 4 to the 8/3. So let's step back and take a look at what happened here. Whatever the exponent was on my radicand, that's this number underneath. Whatever the exponent on that thing is, that actually becomes the numerator in my fractional power. So the exponent on the inside, or actually on the outside here too, becomes the numerator on my fractional power. Whatever the root is becomes the denominator. So here it's a second root or a square root. Here it's a cubed root or a third root. That becomes my denominator. So moving ahead, let's look at what happens. So if we have the nth root of a to the m, I can rewrite that as the nth root of a raised to the m power. And if I want to change that into fractional exponents, the power becomes my numerator, so it's m. The denominator is the root. So there's my n, and the radicand, whatever's underneath that radical, is going to become the base. So I can convert between these two. Sometimes it's more useful to have it in this root form. Sometimes it's more useful to have it in this fractional exponent form. All right, so let's check out, kind of going the other way. I want to write each in radical form. So going from this fractional exponent form to radical form, I know my numerator is going to tell me what the power is on the outside. The denominator is going to tell me what the root is, so that is the cubed root of 2 raised to the 7th. And that's how we would rewrite that in radical form. Same thing here. The denominator becomes my root, so that's a cubed root. This becomes my power. And I can leave that underneath here. And that's my radical form. So for these guys, after we convert to this radical form, we want to make sure that we simplify fully. So I'm going to change this into, I'm going to go ahead and bring this exponent down underneath here so that it is the exponent on the 2. So it's 2 to the 7th. And if you remember, for every 3, whatever the root is, we want to look for 3 of those on the inside. For every 3 that we see on the inside, we can pull 1 of those out. So this is going to be equivalent to the cube root of 2 times 2 times 2 times 2 times 2 times 2 times 2. That is 7. So here's a group of 3. Here's a group of 3. I can pull 1, 2 2's out. So when I go to simplify this fully and write my answer, I end up with 2 times 2, or 2 2's, so that's 4 on the outside, times the cubed root of, I've got 1 left over right here, cube root of 2. So that is a simplified version of this in radical form. Let's do the same thing over here. We want to make sure that we simplify this as far as we can possibly go. So what we're going to look at here is to break this down into its simplest form. So if I take 24, I know that 24, looking at the prime factorization, I've got 2 times 12. This is 2 times 6, and this is 2 times 3. So I've got 3 2's right here for every 24. So I can break that into 2 times 2 times 2 times 3. So let's go ahead and convert this, or move this exponent down here first. So this is 24 squared. And again, if I want to rewrite this, I've got the cubed root of 2 times 2 times 2 times 3. So that's 2 times 2 times 2 times 3. That's 124. And then the second 24 is going to be 2 times 2 times 2 times 3 again. Here's one grouping. Here's another grouping that I can pull out front. That gives me a 4 out front times the cubed root of 3 is left over, another 3 is left over, so that's 9 on the inside. So that's my simplified version of these problems. Okay, so there's a couple examples of those. Again, just to review, we can go from this root form to the fractional exponent form. Whatever the power is, that's going to be the numerator in your fractional exponent. Whatever the root is, that's going to be the denominator in your fractional exponent. All right, another rule that we want to kind of review here is negative exponents. Anytime you have a negative exponent, the rule is we negate or change the sign, and flip or take the reciprocal. All right, so if I have a to the negative m, I need to convert that into, I'm going to change the sign on the exponent, so that becomes a positive m, and I'm going to flip that, so this becomes 1 over a to the positive m. Okay, so a couple examples here, a couple quick ones here. So let's go with 7 to the, let's go 7a to the negative third. We want to make sure that we simplify this, get rid of any negatives in the exponents. So I take my exponent, make that positive. I take the reciprocal of that thing. So I get 1 over 7a to the third. And then simplify as far as we can. So we get 7 to the third times a to the third, which gives us 1 over, little quick calculator work here, 343 times a to the third. So there's my simplified version of that. A little bit more complicated here. Example 2. If I've got, let's say, 2a over 5b squared raised to the negative second. Well, again, this entire thing is raised to the negative exponent, so I want to make sure that I make my exponent positive and flip whatever that thing is. So I've got 2a to the negative 2 over 5b squared to the negative 2. We need to flip it. So this becomes, this goes down to the denominator, so this becomes 2a squared. This flips up to the numerator, so we get 5b squared squared. And notice again, I changed my exponents, made them positive. So we flipped, made them positive, and now I just need to simplify. So this is 5 squared, which is 25. Remember, both of these terms get the exponent applied to it, and then b squared raised to the second is going to become b to the fourth over, same thing here, both terms get it, so 2 squared, a squared, and we're done.